Assalamu alaikum wa rahmatullahi wa barakatuh. So, today we are going to learn how to find out the electronic configuration of an element. Okay, electronic configuration of an element. So before we start to learn the method of finding out the electronic configuration, we must have a brief idea about the concept itself. What exactly electronic configuration is? Electronic configuration means the arrangement the arrangement of electrons, and I hope you know what electrons are. They're the negatively charged particles which revolve around the nucleus of an atom in prescribed, indefinite, in fixed energy levels or orbits, okay, or shells. The arrangement of electrons, that is arrangement over here means the distribution of electrons around the nucleus of an atom in fixed energy levels. And by energy levels I mean orbits, fixed orbits. Okay, so I hope you understood the definition of electronic configuration, because basically we are going to distribute the electrons. Now, to understand this, I'm giving you an example. Let us take an example of sodium, and I hope you know the symbol of sodium, that's Na. Okay, and the atomic number of sodium is 11. The number which is written in the subscript on the left hand side, as you can see, this is the way of writing the atomic number. This is the symbol of the element sodium, and this number which is written as the subscript on the left hand side is the atomic number. This is what? This is atomic number. This is atomic number. And what is atomic number? Atomic number is equal to the number of protons, that is the positively charged particles which are present in the nucleus, and that is also equal to the number of electrons. Okay, so for any atom, the number of protons and the number of electrons, and the positively charged particles and the negatively charged particles are equal in number, and both of them are equal to the number of both of the number of both of the subatomic particles is equal to the atomic number. Now the one question arises: how can we know the atomic number? So many a times I ask my students to learn the first 20 elements of the periodic table. If you do so, you are learning the atomic number. Automatically you are learning the atomic number. If you know the first 20 elements of the periodic table in a proper sequence, so you are learning the atomic number, and by learning the atomic number you know the number of electrons. Okay, so our concern is to find out the electronic configuration, or to write the electronic configuration of sodium. To do this, we are going to follow Niels Bohr's method of finding the electronic configuration. According to his method, this is the nucleus. Let us take an example. Okay, let me draw the structure of atom according to Niels Bohr. So according to Niels Bohr, this is the nucleus which contains protons and neutrons. What are protons? The positively charged particles. And what are neutrons? The neutral particles, not having any charge. Now around the nucleus, the electrons revolve in fixed energy levels. The electrons are revolving in fixed energy levels. Okay, like this. These are the orbits. So the structure of atom according to Niels Bohr and his teacher Rutherford is very similar to the structure of solar system. That's why sometimes the structure which was given, atomic structure which was given by Rutherford, is also known as the planetary model of atom, whatever. Okay, that's the history you will learn in class 9 in details. By the way, let us come to the main point. Okay, so the first orbit is named as the K shell, K. Then the second one is named as the L shell, M shell, M shell, N shell, and so on. Okay, so according to Niels Bohr, he said that the first orbit is K, the second is L, the third is M, and so on and so forth. Okay. Secondly, he told that each orbit or energy levels will contain a fixed number of electrons, which will contain a fixed number of electrons following this rule, that is 2n square. What does it mean? It means n over here means the number n is the number of, or the position, you can say the position of the orbits, the position of the orbits. And n is equals to 1 for K, the first orbit, n is equals to 2 for L, the second orbit, n is equals to 3 for M, the third orbit. So according to this rule, if you find out, you will see that the first shell, let us put 1 over here because K is the first shell. So if you put 1 square, simple mathematics, that is equal to 2. So the first shell, that's the K shell, cannot hold more than 2 electrons, right? Similarly, if you take the second shell that is L, the number is 2, the position is 2, so we have to put 2 over here in this formula. 2 square, simple mathematics, 2 square is 4, 8. That means the second shell cannot have more than 8 electrons and so forth. So if you calculate, you will get the maximum number of electrons which an orbit can contain using this rule. But atoms, they behave in a they always behave in a proper way. They always behave in a peculiar, and they arrange the electrons in a in a particular way. And what is that? That is the first shell of any atom cannot have more than 2 electrons according to Niels Bohr. That's period. The second shell cannot have more than 8 electrons. Okay, I showed you just now. Okay, but according to Niels Bohr, the third shell, the capacity of the third shell is 18 electrons. But what was I trying to say? The atoms, they behave in a particular way. Okay, that is octet and duplet atomic structure. We will learn in higher classes. I'm not going to confuse you because you have exam tomorrow. So I'm just teaching you how to write the electronic configuration simply. So listen to me, the first shell cannot have more than 2 electrons, the second shell cannot have more than 8 electrons, and similarly the third shell, you cannot give it more than 8 electrons. Okay, so the first shell, the maximum number of electrons which it can hold is 2, and the rest of the shells, you cannot put more than 8 electrons in each and every shell. This is how atoms behave till 20th, okay, till 20th position, that is calcium. And in your syllabus you have to learn till 20th only. After that, the way of arranging electrons is quite different, which you will be learning in higher classes. If you take science in 11, then you will learn. Okay, so again I'm telling you, the first shell cannot have more than 8 electrons, and the remaining shells cannot have more than 8 electrons. That means you cannot put more than 8 electrons in any shell which is coming after 1. Okay. Now the example was sodium 11. We have to write the electronic configuration, that is we have to distribute the electrons in the different orbits. So if you take the number, you write over here electronic configuration. So from 11 you take 2, the first shell will have 2 electrons. How many left? 11 minus 2 is 9. Now you cannot put 9 in the second shell. Why? Because I told you that the second shell cannot hold more than 8 electrons. So out of 9 you take 2, 8. So the second shell got 8 electrons. How many left? 1. So you have to put a 1. You have to send it to the third shell, because the maximum number of electrons which the third shell can contain is also 8. So we can put 1. Definitely you cannot take more than 8, but less than 8 is possible. This is the electronic configuration. Now using the electronic configuration, we can draw the orbital structure. That is the atomic structure you are talking about. You asking me how to draw this. You have to take a compass. You cannot draw yani you cannot draw the structure with your free hand. Free hand drawing is not allowed. I will cut marks, deduct marks for that. So electronic configuration, you see, this will be the nucleus. Okay, let me give you the proper symbol. This will be 11 and this will be 23. Actually this is the mass number and this is the atomic number. What is mass number? I told you mass number is the sum of protons and neutrons in the nucleus. And what is atomic number? Atomic number is equal to the number of protons, that is equal to the electrons. Okay, you must know these things. So in the nucleus, what are present in the nucleus? Protons. How many protons will be present? Proton is equal to electron, that is atomic number, so you have to write 11. Or you can write inside the nucleus also, but you have to write it very small. P is equal to 11, or better you can give an arrow at the corner, you can write. Whatever way you can choose. Now neutron, how to calculate the number of neutrons? You have to subtract these two numbers. So 23 minus 11, if you subtract, you will get 12, that is equal to the number of neutrons. Why? Because mass number is the sum of proton and neutron, and you already know the number of protons, that is 11. If you subtract 11 from 23, what are you going to get? You are going to get number of neutrons. So number of neutrons is 12, that has to be written inside the nucleus, or you can give an arrow and show at the corner. Okay. Now let us draw the orbit using the compass. You have to draw a concentric circle, the first orbit. How many electrons is it's going to hold? It's going to hold 2 electrons only. So 2 electrons you have to draw. Now the second orbit. The second orbit, it is going to hold 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And the last orbit is going to hold 1 electron. This is how we draw the atomic structure. I hope you understood how to write the electronic configuration and how to draw the orbital structure.